All right, lesson 10.6. We're going to deal with the world of, well, stay in the realm of similar figures and discuss dilations. Okay, and so what is a dilation? And then we're going to create some dilations using coordinate planes and so on. So those are the things that we're going to focus on here. So first of all, what is a dilation? A dilation is a transformation that changes the size but not the shape of a figure. After a dilation, the image is similar to the original figure, which, by the way, the original figure is called the pre-image. Why? I don't know. That's just what we call them. Okay, it's just some of the mathematical terms that have come up from the beginning. So the pre-image is the original. The image is the result of the dilation, of the transformation. So what we're doing here is we're coming up with similar figures. And remember, in the last unit, I guess I can leave this out here. Similar figures are things that have the same shape, but not necessarily the same size. So every dilation, if it is a dilation, has a fixed point that it was what we call the center of dilation. So so this is our test, in one of our tests, I guess to say, whether we have a dilation or not. Okay, so to find the center of dilation, draw lines that connect each pair of the corresponding vertices. The lines intersect at one point. This is the center of dilation. If they don't, okay, let's just say we draw these lines and they don't intersect at one point, you don't have a dilation. Okay? So that is basically going to be our test of whether we have a dilation or not. So I'm going to go ahead here. Okay, we have A and we have A prime, by the way. This is A prime, B prime, C prime. In this case would be the image. That is the resulting figure. ABC is the pre-image. That would be the original. Okay? But if I draw a line through A and A and A, and I go back here, and I'm just going to leave it out, hanging out here, and then C prime through C, okay, you'll notice that they intersect here. Now if B prime through B intersects at the same point, we have a dilation. Now this may not be perfect, but for our cases, it's close enough. So in this particular case, we do have a dilation because the lines through the corresponding points meet at one specific place. If they don't meet at a specific place, we do not have a dilation. So in this particular case here, we're going to check, is this a dilation? Has triangle ABC been dilated to A prime, B prime, C prime? And I will say here that these two triangles are similar to one another. If I did the ratios of corresponding sides, they would end up being the same. But we're not going to do that here. We're just going to check to see if this is a dilation. So A prime through A, and I'm just going to draw out a ways here. B through B prime. Sorry, B prime through B. So now there is my point so far of intersection. So my C prime through C better intersect in the same spot if it, okay? So it does. So we have a dilation. So if you wanted to even answer this, you know, yes, dilation, you could. Okay? If we were checking to see if it's a dilation or not. Okay? So now let's go check another one. All right, we'll do the same deal. So in this case, I have 4. Let me find my line tool here. There we go. All right, so we have 4 corresponding points. We need 4 lines. They all better intersect in the same spot. Okay, so the L's, the L and the L prime, the M and the S. So far so good. We intersect here. Okay, O and O prime. Uh-oh, we've got a problem. And in this particular point, even if I go N through N prime, we would have something like that. Okay, it doesn't look like this is going to be a dilation, because even if I were to continue these lines, which would take it off of the graph, oops, that's not what I wanted. Yeah, there we go. If I were to continue these, it doesn't look like we would have any common intersecting points, and so this is not a dilation. So not a dilation. Now that doesn't mean that these are not similar figures. They could be. If I were to do the ratios of corresponding sides, we probably here would find out that they very well might be. But it's not dilation. It doesn't fall under that category of transformation. So All right, we're also going to talk about scale factor. And scale factor describes how much a figure has been enlarged or reduced. Okay, so this is the how many times larger or how many times smaller we're making a shape. Scale factors larger than 1 increase the size. Scale factors between 0 and 1 reduce the size. A scale factor of 1 would do nothing to it, because we know anything times 1 just keeps that thing the same. Now we're going to focus on what we call dilations with a center on the origin. Okay, so all of our dilations will be around the origin. And so here is the algebraic formula for it. Our original point x and y, x and y, would be multiplied by the scale factor. Okay, so whatever the scale factor is, 1, 2, 12, 85, 0.34, to find a dilation around the origin, we would take the x and the y, and that's what this is saying here. X times a would give us our new points, x prime and y prime. Y times a. So we're taking the original points, each of the coordinates, and multiplying by the scale factor. So if we do, we have triangle ABC here, and we are going to dilate it with a scale factor of 2.5. So all of these points, 2 and 2, would each get multiplied by 2.5 to give us our new coordinate of A. 3 and 4 both get multiplied by 2.5. That gives us a new set of coordinates for B prime. 5 and 2 both get multiplied by 2.5. Okay? And so again, in each of these cases, you'll notice I'm multiplying all of the ordered pairs, all of the coordinates, by the same scale factor, 2.5. And the result, in this case, would be the coordinates 5, 5 for A prime, 7.5, 10 for B prime, and C prime would be 12.5, 5. All right, so if I were to, I don't remember if I did that. All right, we'll just do it this way. If I were to plot these points, A prime, 5, 5. Okay, and I'm going to approximate 5, 5 would be right about there. I don't have my grid worked out, so A prime would be right about there. Okay, and this again, this is just going to be an approximation. B prime, 7.5, 8, 9. I'm sorry, 7 would be here. 7.5 would then be right about here. Up to 10 would be right about there. Again, this is not perfect. I don't have my grid. I didn't want to mess everything up with the grid lines and make it messier than it has to be. C prime, 10. Oh, I should have put 12 on here. So there's 12. 12.5 would be just after it, and 5 would be right about there. So here would be my C prime. Let me get my tool for drawing. Okay, so here would be my dilation. And again, if I were to draw the lines back through my corresponding points, B prime through B, in this case, all of these lines would run into the origin. All right, so going on. Now, this one we're going to do out just because it gets a little bit more tricky. All right, so each of the points, 3, where our scale factor in this case is 2/3. So we're going to have to take 3 and multiply by 2/3, which in this case then, this is where, multiply by 2/3. All right, this is where we're going to have to do some common denominator work. Okay, or not common denominator work, but fraction work. My whole number becomes a fraction, placing it over 1. Okay, so here we end up with 2. All right, so I'll go over here. A prime, the first coordinate is going to be 2. All right, so 9 now gets multiplied by 2/3. 9 over 1 times 2/3. And in this case, you'll notice a cross reduction here. And 3 times 2 is 6. So I end up with the point, so A prime, my image, is 2, 6. All right, so now 2, 6 over 2 up 6 would be right about there. There is my A prime. All right, if I do the same thing, let me change colors just for the sake of changing colors. Now I've already done 9 up here, so I don't have to redo all of that multiplication. I already know that 9 times 2/3 is going to be 6. So I'm not going to waste the time of multiplying by 9 again, but I do have to do the 6 times 2/3. So 6 over 1 times 2/3. Again, I have a cross molar reduction here, 1 and 2, so that is going to be 4. So 6/4 is right about here. And for C, well, or C prime, here I'm going to go ahead and go to black in this case. Well, C prime, you'll notice we've already multiplied 6 and 3, so let's just use the information I already know. 6 was multiplied by 2/3 and gave us 4. All right. 3 up here was multiplied by 2/3 and gave us 2. So there's 4, 2, and so over 4 up 2 would be right about there. Sorry, this is C prime. This one is B prime. And if I take my tool here, my line tool, and you'll notice that 1, because it's only 2/3, it's slipped closer to the origin, and 2, it's 2/3 the size. Okay, it's a little over half of what it was before. But in this case, the nice part is I had some shortcuts because I was using some of the same numbers over again. But again, each of these numbers here, all 6 of these numbers, are multiplied by 2/3 to give us our new locations for our image points. So, and there's probably some that are going to need some help with this at times. So when you get to those things, please come see me. So good luck.